Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Dolly Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Cece.
And in studio with us we have Giovanni. And if somebody needed to contact us, Giovanni, what would they need to do?
For math homework help, call in Bakersfield 636-435-7. Everywhere else, 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net and social media, Facebook, Instagram, Twitter, and YouTube.
All right, nicely done. A lot of sixes in all those phone numbers, aren't there?
Yeah.
So where do you go to school and what grade are you in?
I go to school at Panama Elementary, and I am in 5th grade.
How was 5th grade?
Good.
What's so good about it?
That it's fun, and like you have to like do like PE, and then like there's really fun math.
Oh, good. Well, fun math, that's always important, right? So what kind of math has been fun so far this year?
Multiplying decimals and a little bit of dividing.
Okay. So that's what you're doing now, right?
Yeah.
What things have you done before, like at the beginning of the school year? Do you remember any of those things?
Yeah.
What were those?
So we did like adding decimals and like subtracting them, and like we were learning how to like do that.
So you're feeling pretty good with decimals.
Yeah.
Have you, I think you said you were multiplying decimals with hundreds,
Yeah.
right? Have you ever multiplied decimals by another number with decimals?
I think so.
Ooh, well, maybe we'll try a little bit of that also today, all right? So you're in 5th grade, it's going pretty well. You like math, you like PE and things like that. Is there anything you're looking forward to in 6th grade?
Like doing like math and like other subjects, like history, geography.
Okay. Have you heard of Camp Keep?
Yeah.
Yeah, can you tell me anything about that? Have you heard anything about it from kids that have gone or are going yet?
No.
Okay, well that's something that you're going to be able to do in 6th grade. And that's where you get to go and experience a ton of science activities. You're going to be right in the middle of everything for a whole week, being able to do all of that stuff. So does that sound interesting to you?
Yeah.
Good, well something else for you to look forward to in 6th grade. All right, well before we get you going to work on decimals today, we're first going to take a look at today's Math in the News. All right, today's Math in the News has to do with somebody, and we're just going to go by the name of Harper is his last name, and he wanted to know how long it would take to count to 1 million. So, Giovanni, how long do you think it would take to count to 1 million?
Probably like 5 hours.
Probably like 5 hours. All right. Here's what we're going to do, okay? We're going to time. I'm going to leave it up to you. Would you like to count for 30 seconds, or would you like Cece to count for 30 seconds?
Cece.
All right. Now, I'm not the one making you do it.
All right.
Giovanni's making you do
Okay.
it, all right? So what we're going to do is you're just going to say that you're going to start counting from 1.
Okay.
And we're going to do it for 30 seconds to see how far you can get,
Okay.
all right?
So do you think I should start out like really fast, or do you think I should kind of like
A
kind of
little
pace
bit.
myself?
A little bit slow.
I should sort of pace myself. Okay.
All right, you ready?
I'm gonna breathe. Okay.
We'll wait to the very top here.
All right.
So, on your mark, get set, go.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68,
Whoa!
69.
You said 69.
Okay.
All right. So she got to 69 in 30 seconds. Let's just say it's 70 to make the numbers easy. So if she could get to 70 in 30 seconds, theoretically, how far could she get in 1 minute?
In 1 minute, there's 60 seconds, so she's at 69. If you add those two up, you'll probably get at 129.
Very close, right? Because if we do 69 and another 69, you're going to get 138, right? So it's very close. 120. You know what? It probably would be 129, because as you get to larger numbers, they're
Oh,
going to
man.
take a little longer, aren't they?
Can you imagine 506,042?
Whatever you want to do,
Yeah.
right? All right. So you originally said 5 hours, right? Do you have an idea on how long? Because I know you haven't seen this unless you knew it from before.
I am going to say, I need a calculator. I would say like,
Yeah, you want a
like,
calculator?
like,
There you go.
500,000 seconds. Because like you say, once you get to those bigger numbers, it's going to take you a really long time to
All right,
say
so
them.
500,000 seconds.
So 500,000 seconds.
If she wants to know
1,
how
2,
many
3,
minutes
4,
that is, what
okay,
should she do?
If she wants to know how much minutes are those, she can probably multiply it.
So
By
if I've
what?
got, yeah.
Multiply or divide?
Multiply.
By what?
200.
So I'm going to go actually, so like how many seconds are in 1 minute?
60.
Okay, so I'm going to divide by 60. That's going to give me 8,333.333333 minutes. And then I'm going to say,
How many minutes in an hour? 60 seconds in a minute, right? And then how many minutes in an hour? Still 60, right? All right, so she should do another 60.
and that is going to give me 138.888888 hours.
How many hours are in a day?
24.
All right, so now she's got to do something with 24.
Going to divide by 24. That's going to be 5 days, 5.787 days.
Let's give you 6 if you like.
Okay, all right.
You
all
like
right.
6 days?
6 days.
All right. Mac, what do you think?
I'll go in the middle, I'll go 3 days.
All right, so we have 5 hours, 3 days, 5 days. And for those of you wondering who Mac is our floor director today. So, if you said one number per second, it would take 11 days, 13 hours, 46 minutes, and 40 seconds. That is without stopping. One number every second. But do you think we can say the number 454,929 the same we can say 2?
No.
They're going to be a little different, aren't they?
Yeah.
So that's assuming you can say one number every second. That's how long it would take to get to 1 million. Now this guy did it, and he obviously had to take time to sleep, right? Because you can't stay up for 11 days
11
counting
days.
nonstop,
He literally did this.
right? So he did it.
Oh,
right?
okay. All right. Then.
So we wanted to know how long it would actually take
Okay.
to do it. And it took him, he did it for 16 hours a day. 89 days later is how long it took. All right? So 16 hours a day, and it took 89 days to count to 1 million. And he had a camera on him the entire 24 hours. He took time off from work to do this. He knew it was probably going to take a couple of months to do it. He thought the summer,
Okay.
but it took a little longer than that.
Okay.
But he did raise $10,000 for a nonprofit he was doing this
Okay,
for.
okay.
A penny per number is what he raised.
Nice.
So not too bad right there, and that is today's Math in the News. 636-4357 is the phone number. We do have phone tutors available until 5:30. We've got Mac on the camera right there, our floor producer for the day. So those of you that were wondering who Mackenzie was, that is Mac right there. There you go. Nice little bow right there. And this isn't your first appearance on the show, is it, Mac? How long have you been with the program? In any capacity?
Any capacity? The entire time.
I was going to say,
All of the 20 years.
So this is your 21st year also.
It is.
All right, so a lot of times she would come to the studio as a student and get help from the tutors, and then she started working on cameras and doing other things, and then she's on her way. So, how you feeling? Pretty good?
Yeah.
All right, you know what? We're going to give you a break because I had you do a lot of thinking right there. We do have phone tutors available until 5:30. As a reminder, if you phone in this afternoon and we do one of your math problems on TV, you will automatically get a pass to Autumn Nights, a brand new light show happening out at COM. Everybody's familiar with holiday lights. It's been around for a long time. It is a nationally known light program. It has often won awards for national light shows and is in the top 10 in national light shows. And that is unbelievable that we have this right here in Kern County. So Josh Barnett, who does the holiday lights, came up with a new light program, and that is Autumn Nights. And that is one where you can walk through COM once again, like in the old days before all of the pandemic and things like that. And here's some footage right now of Autumn Nights, and you can get a little bit of a glimpse of what to expect. This is happening every Thursday, Friday, Saturday, and Sunday evening between the hours of 6 and 9. And in order to go out, you simply can buy tickets, or you can receive one for free by calling in to do the math today as well as next week. They also have pumpkins for sale out there, and that's not Halloween in autumn without the pumpkins and all of the gourds and snacks. You like trains? You like riding on a train? Have you ever ridden on a train?
Yeah.
We know the Colonel. The Colonel is one of the guys out there that runs the train, and he was on the program a couple weeks ago to talk about this. So if you happen to go out there and you go on the train ride, ask for the Colonel. And they'll go, what do you need the Colonel for? Go, I was on Do the Math, because he's the person who's in charge of all of Do the Math. And you can let him know that you were on the show. Sound good? All right, so that is Autumn Nights, happening now until October 30th. Well, on Wednesdays, we often do have an opportunity to head out and about to various businesses and industries throughout Kern County, and here's one for today.
All right, welcome everybody. We're out here at RLH with Jim Shepard. Jim, how are you doing today?
I'm doing excellent, thank you.
I mean, I see fire protection. What is RLH? You know, what are we doing here?
RLH, we are primarily a sprinkler contractor where we put in fire sprinklers for residential, commercial, and big warehouses, aircraft hangars, all kinds of different things.
So anything that might catch on fire that needs to be suppressed, you guys can service?
Yes.
Okay.
Yes. We also do fire alarm systems that detect the fire. Also, they can also activate the sprinkler systems.
Okay.
We also have security systems, surveillance, things like that.
Okay. Because I see the 24-hour video surveillance, security, and then so I'm looking at these batteries and what most people might recognize in different businesses, fire alarms. You have the pull, the strobe light. So do you guys also install those components also?
Yes, we do.
Okay. What goes into designing a system, like for a school or a brand new business building?
There's a lot of different things that go into it. All of these different devices that you see here, you have a fire alarm panel, pull station, you have some modules, smoke detectors, the horns and strobes, and the batteries.
Okay.
Those are typical components of a fire alarm system. NFPA 72 is the guidelines that we have to follow. So one of the things that we're going to talk about today where we use math on a fire alarm system is where the batteries apply. The batteries are there so that if power goes out, we all know about the rolling blackouts and
Right,
stuff
especially
like that.
here in California, in the
Especially
summertime.
here,
Yeah.
yes. The code says that a fire alarm system has to be able to stay alive and functional for 24 hours and 15 minutes of alarm.
Okay.
Okay, so 24 hours in standby, 15 minutes in alarm.
Okay. So, I mean, different size batteries, different size systems. How do you guys calculate how many batteries, how big of a battery? what do you guys? I'm sure that's where the math is at here.
This is
So
where
do you come up with those numbers?
What we've come up with is we've come up with a spreadsheet. Basically, we fill in the blanks and it does the math for us. So I've got our typical components where it says the device and model number. Those are all our typical devices. Over a little more to the left there, it talks about what kind of devices those are: pull station, photoelectric smoke detector.
Okay, so
modules.
depending on how many of each you need for a building, you'll plug it in. It'll tell you how many, it looks like current amps, meaning how many are constantly running through it while like it's live, like on the grid.
Well, if it's just sitting there.
Okay. So once it's installed and it's sitting there constantly monitoring.
Right.
Okay.
It draws a certain amount of current, and then when it goes into alarm, then it draws more current. And so we need to know what all of those values are. And code says that we have to stay afloat for 24 hours.
Right, and that 15 minutes of alarm time.
And then 15 minutes of alarm. So those are both numbers that we have to calculate. And so down here at the bottom, we show that 24 hours, and so I'll plug that value in. And then for 15 minutes, the decimal value of 1 hour is going to be 0.25 hours or 15 minutes.
Gotcha.
Some military projects we have to go 48 hours.
So it just depends on whatever that regulation is.
Yeah, 48 hours, 72 hours, 15 minutes, 30 minutes, 1 hour.
Depends on what they want.
Right.
Well, perfect. We'll send it back to you guys in the studio for now. When we come back, we'll explore more here at RLH and figure out how do they keep the world safe.
All right, thanks for that, Mick. 636-4357 is the phone number. Cece's in studio with us. We also have 5th grader from Panama Elementary, Giovanni. And you ready to do a little bit of work?
Yeah.
All right, head on over to the board. So you said that you've been working with multiplying numbers with decimals.
Yeah.
So I will let you select the first number. So pick a whole number for me between 11 and 70.
50.
50? All right, so let's go with 50.34. So
you
when
wanna
you guys
go
can go ahead and write
left?
that, 50.34. Let's go
Or
3-4.
Or just do 4. Do 4-3.
Yeah,
Since
there
you already
go.
got the
That's
4
fine.
there, let's just throw a 3.
And
on the back
Cece,
end.
what 3-digit number would you like to multiply that by with no decimal in it?
1, 2, 3.
All right, so you're going to multiply that by 123. All right, so Giovanni, I want you to explain to Cece how to do this problem. And if you get a little stuck, she's right there to help you out.
All right, so go ahead and throw the multiplication sign on, and that. Yep, there you go. Okay.
So 3 times 3 is 9. Then you go next, and then 3 times 4 is 12. And then I have my decimal right there, so I'm probably going to add that right there. Go right there. 3 times 0 is 0, but plus 2 is 5.
Okay, I'm going to pause you for just a second. When you did your 3 times the 4, what did you get?
12.
12. So what do you need to carry?
Oh, my 1.
There you go. You said it right. Your pen went wrong. There you go.
4. 3 times 5 is 15.
Okay.
Nowhere else to
Okay.
put it.
When I threw you off when I had you do this, so you did your 12. You carried the 1. 3 times 0 is what?
0, but then I have 1 more, and then it's 4.
So no, 3 times 0 is what?
0.
And 1 more is
4.
no. 3
Wait,
times
what?
3 times
He
0
got
is
that
what?
3 stuck in his head.
0. And 1 more than 0 is
1.
1. There you go. So now 4 is 1. Nice job. Okay, all right. Now you got the 2. Now you can start with your 2.
Then I have no numbers for the 3 to do, so I cross it off.
All right.
Add a 0.
Okay.
2 times 3 is 6.
Okay.
Then 2 times 4 is 8.
Mm-hmm.
Then I add the 8 over here, put the decimal.
Okay.
Then 2 times 0 is 0, so I put the 0 down here. Then 2 times 5 is 10, so I have to put the 0 and then 1. Then I cross that one off.
All right.
Then I have 0. Then 1 times 3 is 3. And then I have the decimal.
Okay, wait. What position is this in? How many zeros do we need to have before we start our multiplication?
Oh, 2.
There you go.
Then I have 3,
There you go.
4. Then I have 0. And then 5.
And I'm going to move the screen for you a little bit so you have room down there to add those.
There we are.
Now I'm gonna add them. 0 plus 9 is 9. And then I have 6 plus 2, and then I get 8. Decimal. 1 plus 8 is 9, plus 3 is 12. Then I carry the 1. 4 plus 5 is 9, plus 1 is 10. Put that 1 up there. 1 plus 0, then I have that extra, and then 2. Then 5 plus 1 is 6.
Very nice. All right, that looks pretty darn good.
So why does the decimal point stay there?
Because if you look at the question, it's at the hundreds, and I have 2 numbers back here, so then I have the hundreds.
All right.
Okay.
Do you know how to say that answer?
6,202 and 8,900.
There you go, nicely done. I
nice.
like how you said
Okay.
that "and" with the decimal point there is exactly what that is. Because a lot of students, sometimes they just go 0.89. But you were all over it, Giovanni, by saying "and" 89 hundredths. And that was beautifully done right there. All right, erase the board. You're on a roll. Let's try one more. So now I will select the number, the decimal, 72.27.
0.7?
27. And you, Giovanni, now select the 3-digit number you're going to multiply it by.
450.
450? All right. And Cece, what I'd like you to do is place a decimal somewhere in that 450.
Oh, let's see. Eeny, meeny, miny, mo. Where should I go? I'm gonna go here. You know what? No, I don't like that. That just makes it 45. Let's go ahead and go here.
Oh, nicely done. All
Okay.
right. So, Giovanni, go ahead and multiply like you normally would, but if you're a little stuck at some point, Cece is right there for you.
So 0 times 7 is 0. So then everything else would be 0, so we don't need that. And then we put the 0, then we don't add them, and then we do 5 times 7 is...
So can I pause you for just a second? How come we don't need the 0?
Well, it's because everything times 0 is 0.
But normally, if I were to do something like this, where I say like 56 times 10, if I were going to multiply that, do I need the 0 here?
Oh yeah, you add
So,
it to the answer.
so no, you're okay. Tell me why I kind of don't need the 0 in this one.
Well, it's because it's in the thousands, but we don't need it, and then it's a
Because
0.
it's on the back end of the decimal. Okay, good. Just making sure.
Then
Alright,
5
okay.
times 7 is 35. Then we add the 3. Then 5 times 2 is 10 plus 3 is 13. Then we add the 1 up here. Then 4 times 2 is 8 plus 1 is 9.
Oh, wait, we were on the 5.
Oh yeah. 5 times 2 is 10 plus 1 11. 5 times 7 is 35 plus 1 is 36. Then if I have that, the decimal would be right here. And then I cross off the 5, and I'm in the 10, so I technically just need a 0. And then 4 times 7 is 28. Then I add the 2. Then 4 times 2 is 8 plus 2 is 10. I add the 0 decimal 1. 4 times 2 is 8 plus 1 is 8.
4 times 2 is what?
8, and then, oh wait, no, and then plus the 9.
There you go.
And then plus the 1, so it equals 9. And then 4 times 7 is 28. And then I have the decimal right there. Now I just need to add them. 5 plus 0 is 5. 8 plus 3 is 11. 1 plus 0 is 1, and then plus 1, 2 decimal. Then 6 plus 9 is 15, and then 1, and then 3 plus 8 is 11, plus 1 is 12, and then 1, and then 2 plus 1 is 3.
All right,
Okay.
so before you guys keep going, I'm going to move it down a little bit for you so you have some room to work
Okay,
with.
so I'm going to ask a question because it's been a while since I've multiplied by my decimals. Does it matter that before, when we didn't have a decimal there, we were able to just leave our decimal, but now we have our decimal over 2 places? Oops. How did I get rid of that? Okay. That I have this over 2 places and I have this one over 2 places. Does that matter? Does that change things?
Technically, no.
Technically, no. Sure? I thought it meant that we went four places. Am I wrong on that? Multiplying decimals, don't I need to move it 4 places?
Indeed you do. Because you have 2 numbers after the decimal in the first one. And on the bottom you have 2 numbers after the decimal, 0.45, because the 0 doesn't really count, like
Right.
you said before.
So
altogether,
we have 1, 2 places, 3, 4 places. So in our final answer, it's not going to be 1, 2 places. It's going to be 3, 4. Our decimal's actually going to end up there after the 3 and the 2. Nope, after the 3 and the 2. So we're going to count our places. So we say 1, 2, 3, 4. So in our final answer, 1, 2, 3, decimal point 4. So how do we say that answer?
32 tenths and 5,215 10,000.
that was awesome, dude. I mean, you did that pretty quick. I'm glad that you know your place values like that. That was pretty good. I'm like, all right, is he going to take a second to figure that out?
That's good.
So we're going to do one more like that with decimals in both numbers, but we're not going to use as big in numbers. All right, so let's erase the board.
Let me erase this one too.
And let's go 0.23
Wait, 0.2.
times 1.7.
1. Wait. 1.7.
All right, so Cece, maybe work with him on how it might be easier to line up
Okay.
the numbers instead of the decimals.
Yeah, so we don't actually, because we just on that last one, we did, we said, well, we can count it out at the end. So really, truly, we can just think about it as just like normal multiplication. So we're just going to kind of do normal multiplication. We're going to kind of, oh, whoops, I did that wrong. We're going to kind of ignore the fact that our decimals are sort of offset and just know that at the end we're going to move it 3 places. So we're just going to do this and just do it like a normal multiplication problem. Just don't even worry about the decimal point for right now.
So 3 times 7 is 21, so we have the 1 down here, 2 at the top, and then 3 times 1 is 3, plus 2 is 5, and I have to get rid of the 3.
Okay.
I add the 0, 2 times 7 is 14, and then I have to erase the 2 and get the 1.
Okay.
And then 2 times 1 is 2, then plus 1 is 3.
Nice.
And then if I add them, 1, 9, and 3, and then if I look at my quotient, I have this in the tens, and I have this in the hundreds, so I would probably do 39 and 1/10.
Okay, so we're going to go back to what we just talked about just a little bit ago. How many places are behind the decimal? So this one in the 1.7, I have how many behind it?
1,
1. How many do I have here?
2,
For a total of?
3.
So we're going to move it. So we're going to start here, and then we're going to move it. 1, 2, 3.
1, 2, 3.
And so yep, there you go. And so you're going to say it how?
0 and 391 thousandths.
Nicely done. And I'm especially impressed with your vocabulary,
I
with quotient
know.
and things like that.
You're
So
going to do really well with the whole fraction thing because you'll know exactly what to put it over. That's awesome.
nice to see that. So we'll keep working on that a little bit. But for your hard work so far this afternoon, you've got yourself a meal at Grillin' Burger. So congratulations on that. Hopefully you have an opportunity to go down to Grillin' Burger, say hi to Lydia. She just loves everybody from Do the Math, and she'll set you up with a great meal. We do have another opportunity to head on out to RLH, visit with Mickey, and see what they're up to now. Mick?
And welcome back out here to RLH. We're with Alan. Alan, how are you doing today?
Great. How are you?
Perfect. Oh, you know, I've learned that you guys not only detect fires, but it looks like you guys also suppress the fires
Yes,
with
we
your
do.
system. So,
100%.
what do we have going on here? I know I constantly ask that question in these segments because really, I have no idea what I'm looking at here.
So this is
What are we doing?
this is a project we did at Travis Air Force Base,
Okay.
up north of San Francisco. a couple of years ago, and it was a good example of a foam, high-X foam system
Okay.
that we did for the Navy, NAVFAC. This is the city that the hangar's located in. This is getting a little closer. It shows some of the structures around it. This is our actual hangar,
Okay.
and this is a blow-up of the hangar.
Gotcha.
So basically, when you have to put out a fire in a high-hazard aircraft hangar, you need two suppression systems. One is a sprinkler system. This is a depiction of the sprinkler system, the actual drawing we submitted to the Navy.
Okay.
You can see the silhouette of the aircraft here. This is a C-5A Galaxy aircraft. It's the largest aircraft the military has. It's a cargo plane.
It looks like it takes up 70,000 square feet
Yeah,
to,
this
to house
hangar,
this.
70,000 square feet, 104 feet tall, very large aircraft in a very big hangar.
Okay.
Fuel is very light, and if you hit it with sprinklers only, like a traditional building, the fuel is lighter than water. It floats to the top, continues to burn, and then it can spread
Because
on
now
the
you're
surface.
giving it a surface to.
You're
okay.
giving a surface to travel on with the water. It's a part of our system. So what the wet system does is it cools the fire down to give time for the foam, the high expansion foam that we're going to look at. It gives it time to suppress the fire, to suffocate it.
Okay. So that's what we have here, the different locations
Yes.
of the foam generators.
Now,
And these
these
are
are
up
the-
in the ceiling?
They're up in the ceiling
Okay.
at various elevations. Now these radiuses around these foam generators show how fast the foam can spread in 35 seconds
Okay.
from the center of the generator out. The operating GPM is 181 GPM at 40 PSI on each of these generators.
So 181 gallons a minute foam coming out.
Mm-hmm.
That's a lot of foam.
Well, that's water. That's,
that's just the
that's
water.
the solution.
Okay.
The CFM is 22,000 CFM coming out of each generator. So the solution
20,000 cubic feet of foam.
per minute. Yeah.
This is a little bit of foam.
It's a lot of foam.
Oh my goodness.
This is the actual generator we used. It's 7 foot 9 inches tall.
Okay.
It weighs 750 pounds, and it's 6 feet square. So they're very, very, very large.
I mean, I know we can't go out to something this large and see the
Right.
foam in action, but it sounds like you have an opportunity for us to go out and see the foam in action and see
Yes, we do.
how quickly it expands.
Yes, we do. We will demonstrate that later.
Awesome. Well, let's get on out to the yard. Let's see this stuff in action.
Okay.
Thanks so much for everything. Appreciate
You're
it.
welcome.
Send it back to you guys in the studio.
All right, that'll be something to look forward to. And I'll tell you, that foam test is simply amazing to look at also with that amount of fluid going into that building right there and then converting into foam. I mean, amazing stuff that they're doing out there at RLH. Giovanni, 5th grade student at Panama, likes everything about math right now. And do you have any idea what you think you might want to do when you get a little bit older as far as an occupation or work goes?
Not really.
Not really? Do you have any idea do you think you're going to have to do math with it, whatever it is?
Yeah.
Yeah, probably. Well, you're already ahead of the game because a lot of kids think they're never going to have to use math in what they do, but everybody's going to have to use math in what they do at some point in their life. So you ready for another one?
Yeah.
All right, here we go. So we're going to take
Okay, go ahead.
4,357, so 4,357. That's fine. Underneath it, you're going to put 636. Now, Giovanni, I want you to put a decimal someplace in that top number. Beautiful. And I want you to put the other decimal after the first 6. So between the 6 and the 3, right there. So what I want you to do is, first of all, Cece, work with Giovanni a little bit about estimating what the answer should be about before
Okay.
you even go ahead and do it.
Okay, so you've done some estimating before?
Yeah.
Well, you just estimated earlier in the show that you thought it'd be about 5 hours. So okay, so tell me what you think that first one is going to estimate it.
So if I go to the 10s, I underline it. I go to the 5. 5 is bigger than the 4, so then it would equal 5.
Okay, so you think it's going to round up to a 5? Okay, I'm just going to put that over here. So you can tell me what to do next with the other one.
3 is lower than 5, so I gotta make it a 6.
Okay. So and I was multiplying, right? Okay. So 5 times 6 is
30.
So we're thinking that our answer is going to be roughly 30, yeah? Okay, then go ahead and do it and we'll see what happens. Get rid of that.
So 6 times 7 is 42. Carry the 4. 6 times 3 is 18 plus 4 is 22.
Excellent.
Carry the 2, carry that 2 up there. 6 times 5 is 30 plus 2 is 32. Carry the 2 down there, put 3 up there. 6 times 4 is 24 plus 3 is 27.
And before you go on to your next place value, Giovanni, you've done great so far. When you were doing the 6 times 3 is 18 plus 4, were you thinking about using your fingers a little bit?
Yeah.
That is perfect. And I want you to use your fingers, right? Because a lot of times you'll hear people go, don't count on your fingers. Well, if they're there, use them, right? Use
It's a
anything
tool.
at all that makes you comfortable
Right.
and helps you out.
Right.
So if somebody ever says, don't count on your fingers, go, okay, and count on your fingers.
You just
All right,
kinda-
because
you
if
just
that's
kinda-
what helps you, do that. Okay, keep going.
And then I cross off the 6, make it a
Excellent.
0. 3 times 7 is 21. Erase that 4. And make it a 2. And then 3 times 3 is 9. And then 2 is 11. And I have the 1 down there. And then I put the 1 up here and erase that 2. Then I'll have a 1. And then 3 times 5 is 15 plus 1 is 16. 6 down here. 1 at the top, and then you do 3 times 4 is 12 plus 1 is 13, and then I cross off the 3. 6 times 2, and then I gotta get these 2. 6 times 7 is 42.
So I'm gonna pause you for just a second. So we already had a 6, right? And now we're gonna do a 6 again. Do you think it's gonna change what it is?
Yeah.
I mean, as far as like when I did it with the 6 here, you think me doing with the 6 here is gonna be a different number?
Yeah.
Okay.
And then I did 4, and then 6 times 3 is 18 plus that is 20.
No, you were right. You carried the 4. I paused you, so you didn't get your 4 put up there. I apologize.
4. 6 times 3 is 18, and then I have the 4, and then I'll have 22,
Mhm.
and then 2 at the bottom, and then the 2 would be up here. 6 times 5 is 30, plus 2 is 32, and then 3 up here. 6 times 4 is 24, plus 3 is 27.
So the only reason I asked you that is because look, when I multiply by the 6, look at my number that I got here.
It's smaller.
Well, it is because I have my 2 zeros, but otherwise,
It
it's
would
the
be
same
the same.
thing, right? I don't even have to really do it. I can just do my zeros and put it there. Okay, sorry. Side note.
0 and 0 plus 2 is 2, and then 2 plus 1 is 3, then 2 plus 2 is 4, plus 1 is 5, then 2 plus 6 is 13, plus 2 is 15, and then 1 at the top. 3 plus 2 is 5, plus 2 is 7, and then plus 1 is 8, and then 7 plus 1 is 8, and then 0 plus 2 is 2.
How'd you magically make those numbers
I was going to
change
say,
color?
I don't know how it's
I don't
happening,
know what
but
happened. That was good. Okay, I like magic. Yay, okay. All right.
little things amuse us.
Okay, I
you
know it's
like
very.
color
I was like,
changes.
oh, I'll be darned. I was like waiting for another change. Okay, so show me where my decimal is going to be. How many places behind the decimal do we have total?
1, 2, 3, 4, 5.
Okay.
1, 2, 3, 4, 5.
All right. Okay, you get to say it.
28 and 85,532 thousandths.
Hundred thousandths.
100,000.
100,000s.
There you go. I was
All right,
just
that was
going to
really
let him
good.
go
That
with
was-
it, but you wanted him to say it, so
Ah,
that's fine. I think he was on a roll all day. He already
Yeah,
impressed me. He
right?
didn't have to do any more. All right,
good.
you
That
feeling
was
pretty
great.
good with that, Giovanni?
Yeah.
All right, erase the board. We are done
We're
with
gonna go
multiplication for
ahead
the
and-
day.
oh, yeah.
I feel as though you have mastered that and you feel pretty good about moving the
You want
decimals
to
now.
get rid of that one too?
So now you and Cece are going to come up with a division problem, but I'm going to want decimals only in the divisor,
Okay.
all right?
And do we know what the divisor is?
It's the box over the number that we're dividing.
So if so our divisor is this one or this one?
This one.
Remind me on my vocabulary.
So
I'm
it's gonna
thinking
be
it's
the
on the
other one,
outside.
so,
It's the
right.
outside. Yeah, okay. Just making sure. Okay, so do you want to pick some numbers? You want me to pick some numbers?
You pick.
You wanted me to pick some numbers. Let's do, I'm going to do you want the decimal out here, right? Okay, so let's do 2.5 on my outside. What do you want to put on my inside? Or you told me I was going to pick my number. Sorry, I didn't mean to throw that back on you. Let's go ahead and let's kind of keep it, we'll keep it there. How's that? Okay, so have you seen something like this before?
No.
You've never seen this before. Okay, so we are going to do,
Hey, guess when you're going to see it, though?
you're going to see it right now.
And this year in 5th grade, you're going to see
That's
this.
true. You're going to probably see it probably within the next couple of weeks. If you're doing that much multiplication, I'm guessing like tomorrow she's going to say, hey, let's divide. That'd be a lot of fun, right? Okay, so here's what we're going to do. Now, and then the reason that we're going to do it is this. Have you ever seen a division problem written as a fraction? I think I'm going to go here. Okay, I'm going to go with some theory here. Have you seen it written as a fraction that we know that if we've got 10 over 2, that's the same thing as what? It's 10 divided by 2, which gives me what?
5.
5. Okay, so fractions are just a division problem, right? Okay, so I know that if I have something like this, if I multiply, have you done this before where you say, okay, if I multiply the top and the bottom by the same thing, what's 10 divided by 10?
10 divided by 10 is 1.
It was 1, right? So I can multiply anything by 1, and it's the same thing. So it kind of gives me this change where 1.0, or just 1 times 10, gives me 10. 2 times 10 gives me
20.
20. Okay, so I know then that the way I can kind of get rid of, I'm not actually getting rid of a decimal, but I'm kind of like, I'm shifting my decimal. The way I can do that is that I can go ahead and I'm multiplying by 10 here. What happens if I multiply by 10 here? What's going to happen to my number if I multiply by 10?
It's going to change.
It's going to change to how? What's going to add on to the end?
The 0.
A 0. So because I'm multiplying by 10 to shift this, I need to multiply by 10 so that I get a 0 there. Okay, so this new problem that I have is now 25 dividing into this number, right? So my decimal has moved, and I say it has moved, it has not moved. I have multiplied by 10, I have multiplied by 10. So this is precisely the same problem as this. Do you think you could do this?
Yeah.
Have you done this before?
Not really.
Shall we try it?
Yeah.
Okay, so does 25 go into 10?
No.
Okay. Does 25 go into 105?
Yeah.
How many times?
2.
Okay, how many, so if I'm doing 25, it's kind of like a quarter, right? So like a quarter is 25. And this is like $1.05. Roughly how many quarters goes into $1?
25?
So 25, so let's count by 25s. 25,
50,
50,
75,
75,
90, 100.
100, right? So okay, so 25 is going to go into my 105. I counted 4 times. So we're going to put our 4 there, yeah? Okay, so 4 times 25 we just said was 100, so we can put our 100, oops, keep doing that, right underneath there. Okay, and we're going to shift. Let me shift this really quickly before you write again. Okay, go ahead and we do our subtraction, and that gives me what?
0 take away, 5 take away 0 is 5. 0 take away 0 is 0. And then 1 take away 1 is 0.
Okay, good.
Then
Okay, and now what do I do?
you got to bring down the 2.
I am going to bring down my 2. Okay, so let's pause. So 25 goes into 52. How many times do you figure?
2.
There you go. All right, nicely done. Oh, see, you're just magic.
Then I take that away. 2 take away 0 is 2.
Okay.
Then 5 take away 5 is 0.
Okay, nice. And then I bring down which one?
5.
There you go.
Then I do 1.
Yep.
And then I get 0. And then 0. I got to bring down the 0. But since I have nothing to take, divide by 0, then I just leave it.
Okay, but so go ahead and bring down your 0, because this is actually an important step. How many times does 25 go into 0?
None.
0. So I do actually need that 0. I'm going to throw that last 0 on there. So what's my answer?
4,210.
Fabulous. That's
Good.
it.
I'm glad you brought up the
Nice.
point about making sure that other 0 was in there,
Yeah.
because what I'd like you to do quickly is take the number he had, 421, and times it by 25 to check and see how close you were. So
Okay.
this is how you can check your problems to see if you did them correctly.
All right, so he's just wanting 421. So go ahead and write 421 times, no, without the 0. Go ahead and leave the 0 off for just a second. Okay, now we're going to multiply it by 25.
Five, then I have 5 times 2 is 10. 1 at the top. 5 times 4 is 20 plus 1, 21. Then I have the 0 because I crossed this one off. 2 times 1 is 2. 2 times 2 is 4. Then 2 times 4 is 8. Then I add them. 5. And then I have 2. And 5. And then 10.
Okay, so you see when you multiplied it without the 0, look, we get the answer back without the 0. So we needed to make sure that we got it with that 0. So we needed that 0. All right, nicely done.
Right.
I
So
like it.
and
High
the reason I
five.
brought that up is because a lot of times your instructor is going to have you do a division problem, and then most often they're going to say, check it with multiplication.
Yep.
Because a lot of students will forget that 0 at the end of it, and then you obviously know how to divide, but then it would get marked wrong on an assignment because kids think, well, I don't need the 0 because it's a 0.
Right.
But you do need the 0.
Yeah, always make sure you're bringing down whatever's there and do that last bit. You're good to go.
Nicely done.
Nicely done.
All right. Hey, we do have phone tutors available until
Right.
5:30 on most Tuesdays and Wednesdays throughout the regular school year. We have one more opportunity to head on out to RLH, visit with Mickey, and see what they're up to now.
All right, welcome back here to RLH. We just finished up working with Alan looking at what the numbers look like when you're dealing with high expansion foam used for fire suppression. And we're out here in the yard with Marty. Marty, how you doing?
Really good. How are you?
Good. So we have a bucket of water. We have some, looks like something concentrated. What are we doing here? What do we got?
So in a high expansion foam, they come in different percentages. This is a 2% concentration of high expansion foam that we get from our supplier. Today we're using only 5 gallons, which is 640 ounces, and 2% of that is 12.8 ounces. So what we're going to do is take out 12.8 ounces, approximately.
As close as we can get.
Yeah.
Close enough for?
Yeah. So that's about right.
All right.
So I'm taking the water out.
Okay.
We don't need that anymore.
Got it.
And I already pre-mixed my foam concentrate,
Okay.
which we're going to insert. And now we went from concentrate to solution.
And just like that, this is ready to be
This
used?
is ready. What happens in a system when it starts going, you have what you call a proportioner. And the system, as the water's going through, it's pushing this foam concentrate in at 2% into the proportion.
Okay, so it's not necessarily mixed in the system,
No.
but the system mixes it as it's being dispersed.
Correct. It's not foam until it hits the end and generates into a foam.
Well, sweet. So it sounds like we have it ready to go. It's been pre-mixed. Let's go see what it
Yeah.
looks like and how it gets dispersed. All right. So it's already pre-mixed. We're over here. What do we have here, Marty? What are we looking at here?
So what we have here is basically a miniature fire system.
Okay.
So I have a little submersible pump. It's acting like a fire pump, which our fire pumps are putting out 2,000 gallons a minute at 175 psi. Right? And
That's a good amount of pressure coming out
so
of
it was
that
really fun to
system, okay.
miniaturize this down so it kind of represents what it really does.
Okay.
You know, in a miniature system. When the fire starts in an airplane hangar, these fire eyes see it.
Okay.
And within 1 second, that fire pump starts. It releases the water, starts the fire pump, and it's moving. So it has to move from the source, right? And you have to get this solution in there and get it dumped to make foam, get it on the ground, and spread within 60 seconds to cover underneath airplanes.
Right. Is that regulation? You got to make sure you are in there on
That's
that
a
line.
military regulation. The other test we have to do is get 1 meter of the entire hangar full of foam within 4 minutes.
Okay, so is that the other reason behind the high pressure is to quickly move that
Yes.
solution through the lines?
Yes.
Okay. Well, awesome. So it looks like once we turn this pump on, we're immediately going to start pumping out. And
Right.
Well, sweet. Let's go take a look.
All right.
All right, Marty, it looks like we have a little sort of simulation sample here. I'm sure no one was wanting to donate a Learjet or something for us to demonstrate this in a hangar. So
No, and I
what do
probably
we
have
have
to
here?
pull a permit just to do it.
What are we looking at here? What are we doing?
So basically, I tried to represent an airplane hangar. My plastic bucket there is representing a hangar that's like 100 or 200 feet wide and 300 feet long.
Okay.
So that plane is representing 737.
Right.
You know,
Massive.
they're massive. Some of these hangars, they put one plane in, you know, a B-52, or it might have 20 F-16s.
Right.
Right? So you're trying to protect this entire building all at the same time. Up here, I have what we represent as a foam generator.
Okay.
And it kind of looks like one. They actually have fans inside of them that are hydraulically rotated. Once the water hits there, it starts turning the fan.
Okay.
All by itself. There's no electronics needed.
Right, that pressure we talked about
Right.
earlier, that's what's spinning that blade.
It's spinning that blade, and the solution's coming out, and then it has a screen on it. A fire inside that might be only the size of this whole pan.
Right.
A real fire. Right, so down there I have a little metal thing with some diesel fuel in it. That'll represent our fire.
Well, let's see what happens when light some fire and suppress it.
All right. All right, fire's going. Pumps are turned on, alarms are ringing.
Just like that.
Wow.
Boom.
And foam's coming out, it's making nice foam. It's not over the fire yet. Now it's going over the fire, smothering all the oxygen in place. You can see how big the bubbles are. This gets really huge really fast.
And this is a small scale.
This
I
is
can't
a
imagine
small scale.
the size of the foam coming out.
And when we do a test, it's a lot of prep, getting ready to go, and then and it's 3 minutes and you're done. That's how fast the test is.
That's it. Man.
And you can see how it's foaming really well, getting really high. This is only that 2% solution.
If someone wanted to get into this career field and into the fire suppression field, into safety and risk management, what would they need to do? Come down and talk to you? Or?
Come down and talk to me. Talk to anybody in our company or any other company that does fire suppression. There's a lot of really good quality workers out there, and they love math. That's one best part about it.
Right.
Is everything about this stuff is math. How we get the foam there, how fast.
Definitely math involved. On behalf of Do the Math, we want to say thank you for helping us do the math.
Thanks.
We really appreciate it. Thanks for your time out here at RLH. We'll send it back to you guys in the studio. We'll see you next time.
All right, thanks.
All right, thanks everybody at RLH, and thank you, Mickey, for doing that. And we were just commenting, Cece and I, about when they open the doors with all that foam, it's just going to come spilling out. But Mackenzie had reminded us that it doesn't just come spilling out.
Yeah.
It all evaporates, correct?
It will evaporate. That is what they told us. There's not a ton of cleanup. The airplanes aren't like totally destroyed because it's like the foam and liquid. So there's not a ton of.
I guess that would absolutely negate the purpose, right? If all of a sudden the airplane was destroyed by the foam as opposed to the fires. Like,
And don't get me wrong, there is like minor, but it's like they can't.
But not like we imagine that the whole thing is covered and you're going to take a long
Yeah,
time to
you're
clean
like, open
everything
up the
out.
doors
There's
and you
just
just
like
walk
a
away.
film, they said, left on there.
A big bubble bath, go walking in there and
Yeah.
try to find things.
Very good.
All right, Giovanni is a 5th grade student from Panama Elementary and has been working on decimals and multiplying them and then dividing them also. But 5th grade, fractions, decimals, and percents is something that you will do at the end of 5th grade. And guess when you're going to do them again?
What?
In 6th grade. And guess when you're going to do them again?
7th,
7th grade. And guess when you're going to do them again?
8th,
And then when are you going to do them again?
9th.
You're going to do them all the way through high school. And then guess what? If you go to college, guess what you're going to do?
Do them again.
You're going to do them again. And let's say you don't go to college, you go right to work. Guess when you're going to do them?
Again.
You're going to do them again. All right, so you're going to do them for the rest of your life. So fractions, decimals, percents will be a part of your life for your entire life. So we're going to work on fractions, decimals, and percents right now. So Cece is going to give you a pretty easy fraction to work with. You're going to turn it into a decimal, and then she's going to work with you on how to turn it into a percent. And then we'll go from there.
Okay. Do we want to go easy, or do we want to go like kind of easy?
Easy.
Easy. Okay, so then let's do 4/5. Yeah, that's a good one. You think we're good?
Well, did you say easy, or kind of easy?
kind of easy.
Oh, good. Oh, well, then that's a good one for kind of easy.
This is kind of easy. Okay, so we already talked about that being a division problem, right? So how would you set it up as like a division problem so that we can get our decimal? You know, have you seen it? You've never seen this before. You're like, I have no idea what you're talking about right now. Okay, but if I were to tell you 4 divided by 5, how would you set it up?
By putting the 4,
Does 4 go under or on the outside?
in the under.
Because I'm doing 4 divided by 5. So this is the same thing. I'm going to read it this way, 4 divided by 5. So same thing, right? Okay, so now what are we going to do here? Does 5 go into 4?
No.
So we're like, nope, can't do it. We're done. 0. Forget it. It's over. You think? No, that's not what we're going to do. But we are going to say 5 doesn't go into 4, right? So if 5 doesn't go into 4, yeah, we kind of do have like, oh, we're like, oh, it's 0. Okay, 0 times 5 is, okay, if I subtract, I've got 4. But I'm kind of stuck here. Don't we normally bring something down? We do normally bring something down. Now look at this. If I do decimal and I do a 0 there, okay, what's going to happen? What do I bring down?
You bring down the 0.
I'm going to bring down a 0. Okay, so now is 4 the same as 4.0?
Yeah.
Okay, so I didn't really change anything, right? I just kind of said decimal 0. I know I'm okay, right? Okay, I'm going to bring down the 0. Can you tell me how many times 5 goes into 40?
8.
8. Okay, now look at what I'm going to do. I'm going to say, okay, my decimal that I put in there, I'm going to throw that there, and I'm going to say, look at what I've got now. There's my answer, 0.8. Or, excuse me, no, go ahead, say what it is.
0 and 8/10.
Fabulous. Okay, fabulous. Okay, so we now know, and actually, the fact that you just said that, look at this, 8/10, which is what you just said. 4/5 is the same thing as 8/10. Okay, we'll just leave that aside. All right, so we've got this, right? So we've got this decimal. We've got 0.8. Excuse me, we've got 8/10. All right, so we were talking before we started here, and we were saying, okay, what does percent mean? Do you remember what I told you what percent means? Percent means out of 100. So we're saying how many things out of 100 do we have? So if we have 8/10, right, but we're saying we want it out of 100, we need to go to our 100th place, right? So can you show me where our 100th place might be? If we're going to take my decimal to what am I trying to say here? Where's my 100th place in that?
Right here.
Aha, so look at how many hundredths we have. So guess what my percent is?
Your percent is 80 over 100.
Okay, it's 80 over 100. So since we said it's 80 out of 100 is percent, my percent is 80%. And that's all we got to do.
And that's a nice, easy one to start with right there. Right. So it was kind of easy, you said, right? Because you could have just started with 8 over 10, but you had to convert 4 over 5 first.
Right.
So there are a couple of activities going on this week and this weekend. First of all, coming up this weekend is Via Arte, so a lot of people are familiar with that. And we did have some folks from the Bakersfield Museum of Art come in and talk to us a little bit about Via Arte and how to measure things out. That's going on this weekend out at the marketplace. And earlier this week, we were talking about Math Week, and that is something you can go online and check that out. There's the QR code. Also, you can see the website on there, and they're trying to get to 500,000 minutes. They're closing in on 200,000 minutes right now. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Dolly Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.